What's going on, everyone? Lalit here. Snowflake is IPOing on September 15th. This video is broken up into part A, what Snowflake actually does, and at the ending, more of that stock, news, IPO analysis. So please feel free to jump forward as needed. But with that, I'll see you on the other side. Snowflake is a cloud data platform dealing with the storage as well as the capability to analyze huge amounts of data all on the cloud. I think it's important to understand what they're really doing, and what they highlight is 6 aspects on their website dealing with data and the world of data, as well as challenges in the industry, and finally, how they're that much better, naturally. So let's get straight into it. So we'll start with data engineering. Data engineering basically deals with the transportation of data from one system to another. So for example, if you input data into a mobile app, for example, of a new account registration, and let's say you're doing the same thing on a desktop app. So there's information like your first name, your last name, address line 1, address line 2, zip code, phone number, etc. How that's inputted in the mobile app and how it looks like in the backend may be different from how it looks on in the backend after making that same account on the desktop view. So some of the challenges of data engineering, it goes like this. So you have data in different formats for batch and streaming. You have slow ETL, ELT due to resource contention and information like this. But what it's really saying is basically you have this data coming in from different areas because it's siloed. And because it's siloed, it's not uniform or standardized. And we need to standardize it. And that process is known as ETL, which extract, transform, load, which basically is extracting the data from one source, transforming that data into the format or style or type that you need and want, and then loading it into that next system for it to be a final system or the next step. It just depends on the data architecture, system architecture, which are concepts related with data engineering. And so it says complex pipelines and architecture, and that happens over time sometimes. Sometimes it's created so long ago, like a legacy system, and it's what it is. And today, it's 2020 and life goes on. So with that, the next slide is basically saying that it's slow, limited decision making. So, which is totally true because the process just isn't streamlined, and that's where Snowflake comes in. So you have all data, any speed. So it says structured and semi-structured data, batch and continuous data ingestion, partner ecosystem, and there are other points over here. But what I'll highlight is basically saying that structured data is basically saying that, let's say that same example with the account, you have my name, Lalit, first name, Devraj, last name, then you have address line 1, address line 2, zip code, phone number like this. But that's structured data where there's a specific field and then you have some information within that field, right? And semi-structured is just not as structured, but I'll leave the definition out of it and we'll keep going. The batch and continuous data ingestion process, that's important and that's huge because of it being on the cloud and everything is connected. This streamlined process is what Snowflake is basically saying, where instead of having the information coming through the mobile app, for example, and that information, let's say, is passed on to the next step every 3 hours because of the computational limitations of the system itself for a company, where Snowflake comes in is that it's so powerful that it can literally do that instantaneously in real time. And so they're saying continuous data ingestion because there's that much power in the cloud, and any inputted information, any information input can basically just go on to the next step instead of someone manually intervening in the process, maybe them changing the format, and they're just time and time and time. So it's totally streamlined. And here's an example. So Rakuten rewards. First bullet, 95% faster runtime with dedicated resource. Second, you have single source of truth for internal users. And finally, you have secure data sharing with partners across 3,000 plus merchants. So the first bullet is basically saying that if you have this dedicated resource, aka Snowflake, you're able to basically streamline that whole process from, let's say, A to C. That means you have A to B, then B to C. So this whole process is taken care of by Snowflake versus going A to B, then at B, you have to wait maybe a day for someone to do XYZ tasks as a part of their job. And then there's someone else who has to validate and then make sure. And then that goes on to step C. And then maybe something's not wrong, then it has to go back. So all of that is basically streamlined with Snowflake. And that actually leads us to the second point with single source of truth for internal users. So there's a concept in data and it's known as master data management, MDM for short. So in MDM, basically Snowflake is acting like an MDM tool where these validations are made and checks are made on data and data quality. And so there's a concept of the golden record. So the golden record or single source of truth, basically it keeps that integrity for the data itself. And that's huge in data quality, accuracy, consistency throughout systems, etc. And finally, secure data sharing with partners across 3,000 plus merchants. It all goes back to that partner ecosystem that Snowflake has as a USP, unique selling point, where it can communicate data to other users slash other, let's say, folks that it needs to send that data to, and vice versa. And it all comes back to business intelligence slash data insights that can be made from the data at hand. But let's move on. So we have data lake. So a data lake essentially is, I'll give an example. If you download something and you don't really pick a folder, a specific folder every single time you download something, let's say on your laptop or computer, it'll go, let's say if you're using Windows, to the downloads folder. And you can have PDFs in there, you can have Excel, images, PPTs, whatever it is. And so that's essentially a data, let's say a data lake. And a data lake is basically saying that everything, it's a lake of just everything. And the goal of it, according to just general what the data lake was meant to in terms of a goal, is harness a variety and velocity of volume of big data, eventually perform analyses on the data, and minimal cost and complexity. So what it's really saying is that if you have all this data in one space, basically you should be able to get some value, some insight from it. And moreover, it says minimal cost and complexity, again coming to only having one area for all of this data. And so some of the challenges with data lakes, you have copies of data. Just for example, if you have a final version of something, let's say you name it final, then you do it again, final, and you're like, oh man, I need to make one more change, maybe go final. And maybe someone else out there is naming their documents of final documents as final, for real, or something like this. It's not good practice, but that is a very real circumstance that could happen, especially when we look at the fourth element here of insecure and ungoverned. It's basically saying that ungoverned goes back to a concept of called as data governance. So data governance are agreed upon rules / structures / agreements basically of data and data practices that should be held for good reason for the quality of data in general and the integrity of data. And so when you talk about ungoverned data or ungoverned practices, it's basically there's no rules, no structure. And in the end, that's going to be even harder to go through that data lake to actually sift through the information to figure out what needs to be done. And the insecure part is basically that it all goes back to permissions, maybe of who can access the data lake, who can input things into the data lake, who can take things out, who can delete, who can modify. And that insecurity means that maybe they're not able to track the lineage of certain actions, of certain deletions of certain documents, certain modifications. And that's a story of itself. But that's an angle where Snowflake comes in, where basically you have secure and governed, you have consolidated data, you have fast scalable analytics because of the cloud and cloud computing power. And it's simple and cost effective because they already have the system in place, and it's not necessarily that there's a lot of guesswork per se, but there's at least that structure that allows someone to analyze and take it one step further from the data lake. So next we have data warehouse. So a data warehouse, essentially, the goals of it is that it wants to centralize all data. You have an ability for fast reporting and analysis for all users, and low maintenance and cost. So it sounds just like it is. Imagine like a Costco. It's like a warehouse of sorts where you have sections within the warehouse and it's managed in a certain way with all the inventory being data in this perspective. And from that data warehouse, you're able to get BI, for example, business intelligence or analytics / basically information that can influence the business based on the information that's in the data warehouse and how it's analyzed. And so some of the challenges with data warehouse: slow performance, tuning required, significant DBA, database administrator, time on routine activities, and slow analyst access to data. And so this comes back to the data warehouse, the warehouse itself. So for example, let's say if Costco, it's packed, it's on a Saturday morning, or like pre the illness, for example, it was always packed and you have to wait outside the line and things are actually limited. So what's the point here? Basically, there's a bottleneck because users are trying to access the same resource multiple times. And within that, whenever data is actually put in a warehouse, it also needs to be placed. And so that takes up, in this case, the DBA's time, and then also slow analyst access because they just even can't access the actual inventory, even though they know it exists, but they can't get it. So that's kind of one of those analogies. But where Snowflake comes in It's literally right there. DBAs spend more time on high valuable activities. What they're indirectly saying, for better or worse, is basically they do save a lot of hands-on time on the manual intervention that they may need to do. But I think it's also indirectly saying that the future of DBAs dealing with data warehouses, it could be more automated. That's just an insight that I have when I think about it. But faster analyst access to data. Naturally, the whole point of Snowflake here is that speed, that cloud computing capability, and you can pay as you go. And there's other information we'll get on in the IPO side, but that's a very, very big advantage. So the ever-expanding ecosystem, they have so many partners over here. It's crazy. And it's a concept called a data cloud, which is another unique selling point of Snowflake, which I'll talk about in the IPO section. So coming back here, next we have data science. So simplify and accelerate machine learning and artificial intelligence. So if you've ever heard AI, ML, it stands for artificial intelligence, machine learning. And so they say data science is powering innovation. So these are some facts. I won't read it here. You can pause and read it for time. And next we'll see the challenges with data science. So again, finding and securing data is time sensitive. So it's siloed again. And what is data science? Data science is basically dealing with the data and getting those insights or taking it to that next level. And the biggest thing here is 80% of time is spent on finding and preparing data, which it may sound ridiculous, but it's just a fact. And what does that mean? It means that if you move on where Snowflake is concerned, you have more of the capability to actually do the data science kind of roles and responsibilities. So here you have, again, consolidated source for all data, structured, semi-structured data, data sharing and exchanges. Then there's efficient data prep with SQL. So dedicate computer clusters for each team, no resource contention. That's a huge one. Then finally, extensive partner ecosystem. So you have the capability, for example, with Alation, with Alteryx, with Calibra, with other companies out there where basically the computing power, but also what you're trying to do with these tools and interactions, you have those partners in this ecosystem. So the integration with the latest ML, machine learning tools and libraries, consistent experience for BI and ML users, BI standing for business intelligence. And now we have data applications. So data applications, what it's really dealing with over here is that they're saying that today, most apps today have become data intensive. So Customer 360 is something similar to, it's not exactly know your customer from the financial services industry. If you've seen KYC, AML anywhere, for example, in Bitcoin, AML stands for anti-money laundering. But Customer 360, and I was doing the research on this, and while I was doing it, Petco, the company, was basically explaining their whole aspect of Customer 360 and Snowflake, and how they're able to get more insights of what their customer, the whole like 360 angle. So let me give an example, it's probably better. So for example, customer went to the store and it was, hey honey, can you get the dog food? It's the red bag, and it's like, which bag is it, And so what they were saying was, through the Petco app itself, you can see previous order history, but you can also see what type of dog they may have, what age, what breed, etc., and then make more informed decisions based on that data and the insight you can get from the data itself. And so knowing more about the customer is not just giving that personal profile from a satisfaction on the customer side perspective, but it gives more insight for a business on how to capitalize on the next steps in terms of revenue generation from their customers, etc., all based on data. And so some of the challenges naturally are here. One point I do want to highlight here is technical debt. So technical debt basically is saying, let me give a real life kind of equivalent example. For the average person, let's say we have an iPhone 4 whenever it came out. This year it's 2020. You can still keep the iPhone 4, but maybe it won't be up to the standards of today regarding all the apps we're using today in terms of capability of processing and otherwise. So that technical debt, you may save the cash up front for not buying the new purchase or upgrading or whatever it is, but what happens? In the end, you may not be able to access certain apps because of certain upgrades that took place, which means it's only compatible with iOS, however it works. I'm an Android user, but anyways, so you get the point. So it's kind of one of those, and it's up to you. But with companies, that debt is huge, because if you don't upgrade or go to the non-legacy systems, not the older systems, but keeping up with the current kind of programs and tools out there, with data being so hefty, so much to be processed, so much power that's needed, that debt, it's not upfront that you see the cost, but it bleeds, and it's a topic of its own. So let me move on. So where Snowflake comes in, build massive scale data apps without operational burden. So unlimited scalability and concurrency, that is so true. They have their clusters in the Snowflake network, and you can basically pay as you go. Again, fast forward accordingly. But in this model, at a high level, what you can do is access the whole Snowflake network. So each Snowflake is its own kind of piece of the puzzle here, right? And so that cluster can access more power through more snowflakes like this. So it's pretty cool. SQL for all data and no SRE, DevOps burden. Yeah, I don't want to get too technical. I will skip this, but using your own language. You can have that choice. It's not totally you're stuck with one language, which that's another huge advantage of itself, where you can have multiple folks of different skill levels and experiences and backgrounds deal with Snowflake, but interact with it and do what's needed accordingly. So next we have data exchange. Data exchange, empower your ecosystem to securely collaborate across all data. So companies are always looking for a better way to exchange data, share without copying or moving data, access live ready-to-query data, securely source external data. So share without moving or copying data. What it's really saying is that you don't need to move or copy paste or do any of these type of things. All the data is in one place, all in the cloud, and concurrently actions can be made at the same time. So a real life example is, for example, if you use Google Docs or Google Sheets, you can actually collaborate with other team members, friends, or another person in general. You can have two people on the same sheet at the same time, live, updating, and your changes would be saved and theirs would be changed either, no issues. And so that's basically dealing with sharing without copying or moving data. Access live, ready-to-query data. So you can actually do certain, and it's in the demos when it gets more technical, but at a high level, when data is basically manipulated and let's say there's finalized data, you did some transformation to it or some actions to it, that same data it's instant. You can query again that same data in real time without waiting for some other loading process or it to go from one area to another, etc. So it's really efficient. So some of the problems with data exchange: siloed, diversified data, must be copied and transformed; stale and insecure data, complex, costly, outdated. That's what it basically means, right? And this is the before of traditional data sharing. So take a second, pause if you need to. But essentially, there's data sources. Then from the source, you have to take what you want. Then from what you want, you may need to change it a certain way for it to agree with this delivery box of what we have over here. So that's that. But Snowflake streamlines this whole thing where you have a data partner on the left, you have the Snowflake data marketplace, and over here it does show your Snowflake account. And on the right is employees, customers, vendors, partners, your data exchange. And so just from this, it's basically the central repository is what you're interacting with instead of all these multiple systems. So that's one of the big unique selling points for Snowflake. And so advantage-wise, all data is centralized, shareable, data doesn't move and is ready to query, data is live and secure, equaling reduced costs while securely sharing data. Snowflake stock is going to open between 75 and 85 a share. If it opens at $80 a share, you're talking about a market cap of $22.3 billion. Warren Buffett and Salesforce, ticker symbol CRM, have invested $250 million each into Snowflake. If you look into Salesforce, them owning Tableau, a data visualization software, and them investing into Snowflake, if you combine the two in terms of where the synergy could exist, you're talking about data and high computing capability, along with the fact that you can actually make that data look alive and get even more insight into one of the assets that Salesforce has, aka Tableau. Moving on to leadership, if you consider Frank Slootman, look at his track record. In summer 2003, few millions in the bank for data domain. 7 years later, breaking $1 billion in sales. That speaks for itself, and he has clout in the industry, and he was brought in to even lead Snowflake into this stage to get it to IPO. What is all the hype considering Snowflake? It's something they refer to as the data cloud. And essentially, if you're a customer of Snowflake, you have your data, and let's say it's a snowflake and it looks like a snowflake. Other companies would also be these snowflakes. And so long term, whether the same industry or otherwise, you can have this partner type of reach and actually get insights not into your own company's data naturally, but into the industries and across multiple different industries, depending on if that's what the company desires. So that's next level in terms of analytics. Second, it doesn't matter which cloud service provider you have, whether that's your Amazon Web Services through Amazon Redshift, for example, you have Microsoft Azure, you have Google's BigQuery, etc. It doesn't matter which of the big folks you're with, because in the end, Snowflake is compatible with them, and that's what allows users, employees, companies in general to get that insights and data regardless of which cloud service provider they're with. From a financial perspective, let me cut away for a screen share, and I'll be right back with what I'm planning on doing with the IPO.
All right, so looking at their balance sheet, it looks like this. And overall, look at that revenue. Basically, if you do the math, it's around 174% approximately from 2020 to 2019 specifically. And then if you look at 2019 and 2020 in the 6 months, so that's specific to 6 months, so it's not even the full year. And if you look at the revenue, it goes 104 in 2019 to 241 in 2020, and that's only in 6 months. So it's almost the whole year of 2020, but they've done it in 6 months. And a big point I want to highlight over here is if you look at the line item for sales and marketing, it goes from 2019 to 2020, it does 125 to 293, and then these 6 months ending in July 31st, it's 137 and 190. So effectively, they've spent less in sales and marketing, but if you look at revenue, it's almost the same, which is a huge, huge, great trajectory for Snowflake.
So what am I doing? Am I going to buy Snowflake? IPOs are IPOs in the end, and in the end, investing is different from the emotional or logical standpoint. The stock market doesn't really act with the same value that a company may have. And so from that reasoning and just seeing how much hype there is, I definitely will be investing into Snowflake. But at the same time, I won't put all my eggs in one basket on day one on IPO day, because the hype is just too crazy. And regardless of where the price goes, I think just with IPOs in general, I think DCAing, dollar cost averaging in, is always wise. So let's see what happens, but I'm excited, I'm hyped. I hope you got something out of this, and I hope that the first half of this video, it's not really half, I know it's longer, it was more informative onto the more day-to-day on what Snowflake actually does versus just, kind of guessing and checking. So hope it was helpful, and from an investment standpoint, you know how it is. Man, good luck to everyone out there. Let's see what happens Tuesday, but yeah.